Hi everyone, in this video we're going to be reviewing Chapter 7. Just like in the Chapter 6 review video, I started out by just making a list of all of the formulas that were used in this chapter. We're looking at some different tests for population parameters. So we did a z-test for the mean when sigma was known and when sigma is not known. When it's known, it's a z-test. When it's not known, it's a t-test. And then we also looked at z-tests for proportions. There's a really great overview in your textbook on page 402. It gives a complete summary of all the different types of hypothesis testing, how to create the null and the alternative hypotheses, how to go about each of the tests, and then how to make your decision at the very end of the test, whether you reject the null or you fail to reject the null, both using either a p-value or the rejection region. So if you can, take a screenshot of page 402 and have that handy while you're going through some of these problems, I think that would be beneficial. And then obviously having the t-distribution and the z-score table handy would be helpful as well. So let's go ahead and get started and go through some of these problems. Number 1, state the null and alternative hypotheses. A company claims the mean life of its AA batteries is more than 16 hours. Okay, so I'm picking out some keywords here. Mean, more than, and 16. The mean is more than 16. So whenever you see the symbol strictly greater than or strictly less than or not equal to, those are all symbols of inequality, and they go with the alternative hypothesis. The null hypothesis is always a statement of equality. These two things are also complements of each other. So if the alternative hypothesis is the mean is greater than 16, then the null hypothesis must be that the mean is less than or equal to 16, the exact opposite of the other statement. So in this case, we're looking at C as the pair of hypothesis statements. Number 2, state the null and alternative hypothesis. A student claims the mean cost of a textbook is at least $125. Okay, so again, I'm picking out that the parameter here for the population we're talking about is the mean, and it is at least $125. So the mean is at least 125, meaning that it could be 125 or it could be 126 or anything higher than that. So the mean is greater than or equal to $125. Since this is a symbol of equality, I know that this must be the null hypothesis, and the alternative is its complement. So the complement of being greater than or equal to something is to be less than something. So this must be D. Number 3, true or false? Testing the claim that at least 88% of students have a cell phone would be a right-tailed test. Okay, so a claim that a proportion is at least 88% would be P is greater than or equal to 0.88. Now that's a statement of equality, so that must be the null. The alternative is the complement of that, so proportion is less than 0.88. And whenever we are deciding on the nature of the test, whether it's right-tailed, left-tailed, or two-tailed, it's always determined by the alternative hypothesis. So the way that this is stated with a less than, strictly less than symbol, the type of test here would actually be a left-tailed test. So would it be right-tailed? No, it would be left-tailed. The answer here is false. Number 4, you are testing the claim that the mean cost of a new car is more than $25,200. How should you interpret a decision that rejects the null hypothesis? Okay, you're testing a claim that the mean cost is more than $25,200. So that statement would look something like mu is strictly greater than $25,200. So that would be the alternative hypothesis, because that is a statement of strict inequality. which means that the null hypothesis would be something like the mean is less than or equal to $25,200. Okay, now the question is asking us, how should you interpret a decision that rejects the null? Okay, so if I have the evidence to reject this, that means I can support the other statement. If I have the means to reject the null hypothesis, that means I have what it takes to support the alternative, which the alternative is how we came up with the claim, right? We were taking that that first sentence there that says the mean cost is more than $25,200. The claim is the alternative hypothesis. So I'm rejecting the null, I'm supporting the alternative, and the alternative is the claim itself. So there is enough evidence to support the claim. So 4 is B. Number 5, true or false? Given the null hypothesis says that the mean is equal to 40, and the alternative hypothesis says that the mean is not equal to 40, and we have a p-value of 0.0436, you would reject the null hypothesis at the 0.05 level of significance. Well, whenever we have a p-value, we're always comparing that to the level of significance. P is compared to alpha, and the rule is that if p is less than or equal to alpha, let me show you where this is at in the textbook, towards the bottom of that review summary page in chapter 7. Whenever p is less than or equal to our level of significance, right at the bottom here where it says decision rule, that's when we reject the null. If p is greater than the level of significance, we fail to reject. So in this case, we reject, and when p is greater than alpha, we fail to reject. So in this case, I have a p-value of 0.0436 and a level of significance of 0.05. Well, 0.04 is definitely less than 0.05, so that falls under this first category here. We've got the evidence to reject the null hypothesis. So number 5 is A, true. Number 6, find the critical value Z0 for a left-tailed test at the 10% level of significance. Okay, well, if our critical value is a z-value, that means that we're using the inverse norm function from the standard normal curve. So left-tailed test means that our rejection region is going to be down here. And I'm going to put that entire level of significance down here in the left tail. So that area is going to be 0.10. And I want to come up with the critical value Z0 that does that. What z-score would trap 10% to its left? So we go over here to the calculator and we do second the variables button, gets us into that distribution menu, and I want to go down to where it says inverse norm. So I want to work backwards. I want to give it an area and figure out what z-score would trap that area. I'm going to put in the 0.10. And the z-score that would do that would be about negative 1.28. So number 6 is C. Number 7, find the standardized test statistic z for the following situation. Our claim is that mu is greater than 15. I have a sample average of 13.6, a sample standard deviation of 3.4, and n is equal to 40. Okay, well, all of this information right here is telling me that this is coming from a sample. I don't know anything about the population standard deviation. Sigma is not known. So in this case, I have to do a t-test. And we find that in our formula sheet at the top. We'll just scroll up right here and check it out. So t-test for the mean, we're going to take x bar and subtract mu and divide this by the ratio of the sample standard deviation divided by the square root of n. Okay, so t is equal to 13.6 minus our mean, which is 15. Divide this by the sample standard deviation, 3.4, divided by the square root of 40. Come over here to the calculator, put parentheses around things to make sure that your operations are staying in the numerator and the denominator respectively. So I'm going to put parentheses around the difference in the numerator, and I'll put parentheses around the ratio that's in the denominator. Close the square root, close the denominators, ratio, and we get something like negative 2.6, which looks like B. 7 is B. Number 8, find the critical values T0 for a two-tailed test. Two-tailed test, so I know I'm trapping area above and below in a T distribution. Okay, a two-tailed test where our level of significance is 0.05. Okay, whenever you have a two-tailed test, the level of significance for the rejection region gets separated or divided in half. So we'll literally have 0.025 in the left tail and 0.025 in the right tail. And we've got a sample size of 8. So if we're working with the T distribution, that means n-1 degrees of freedom. So we're working with 7 degrees of freedom. Let's go to our appendix here to the T distribution. Okay, 7 degrees of freedom, two-tailed test of 0.05. That looks like critical values of plus and minus 2.365. So 2.365 up here and negative 2.365 down here. That looks like D. 8 is D. Number 9, use technology to find the p-value for the following test. We've got a null hypothesis where the mean is less than or equal to 20. The alternative is that the mean is greater than 20. Sample average 21.3, sample standard deviation 2.1, and a sample size of 16. Okay, to do t-tests on the calculator, we're going to use the stat button. So we're going to hit stat, and then we want to scroll over to the menu that says tests. You can probably figure out after watching this how to do a z-test, but this is really the only way to get p-values for t-tests. So this is really why the textbook only goes through the technology directions for this particular situation. It's pretty much the only way we have to find p-values when the population standard deviation is not known. So we're going to scroll down and hit t-test, and there will be two options here. You can either put raw data into a list and then select the input as data, and then you'll pick like list 1, 2, or 3 wherever you entered it. Or you can scroll over and just put in the stats if you know them. And in this case, we do, right? I have sample average, I have sample standard deviation. So under t-test, I want to make sure that stats is selected. And then I'm going to scroll down and enter in everything that's given to me. I know that the population mean is assumed to be 20, so I'm going to enter 20 in here. X bar is 21.3. Sample standard deviation is 2.1. And N, our sample size, is 16. Now, I have to decide on the nature of the test, and again, that is given by the alternative hypothesis. So I'm looking at this statement. And it is mu is greater than 20, so that is a right-tailed test. So I want to make sure that greater than mu, that symbol there, is selected. And then we're just going to hit calculate. So from the output here, it looks like our p-value is 0.0128418019. That is going to round to A. All right, last problem. Find the standardized test statistic Z for the following situation. Our claim is that the proportion is not equal to 23%. I've got x equal to 52 and n equal to 200. So this is some kind of situation simulated where I've surveyed maybe 200 people and 52 of them said yes to some question that I've asked them. In order to come up with some standardized test statistic, I've got to have my p hat value, right? And that is always equal to the number of people out of the total number that were asked. I've been setting this up right here. Total number of people who said yes or replied in a certain way out of the total number of people surveyed, which in this case is 52 out of 200. 0.26. So now I want to calculate the standardized test statistic, which if we scroll back up to the top here and look at our formula sheet, our standardized test statistic is p hat minus p divided by the square root of pq over n. Z is p hat minus p, so 0.26 minus 0.23, divided by the square root of pq over n. So if p is 0.23, then q must be 0.77. 1 minus p is going to be q, and we're going to divide that by n, which is 200. Okay. Now, a little bit trickier with the parentheses here. I've got to make sure that the operations in the numerator stay in the numerator and that we keep that entire ratio in the denominator inside the square root symbol. I want all of this to stay under the radical. So I'm going to open a set of parentheses and do 0.26 minus 0.23. Close that difference, so that subtraction is going to stay in the numerator. Divide it by the square root of, now I'm going to open another set of parentheses because I want the product 0.23 times 0.77 to stay in the numerator. Close that set of parentheses, divided by 200, and then I want to close the radical symbol. So 1.00815 should round to about 1.01. And that concludes our review for Chapter 7. Obviously, in the textbook, they go through quite a few examples of exact situations of testing, certain sample statistics and seeing how close they are to some kind of claim. So make sure you go through the examples in the textbook. Have these formulas ready for your exam, have them written on some kind of formula sheet, and even, take a screenshot of that page in the textbook that goes through the review process for hypothesis testing. If you have any questions, please let me know, and I'll see you in the next video.